Hello everyone, in this problem we have to find dy dx. So we have to find the derivative of y with respect to x. And we're told that the sinh of y is equal to the tangent of x. So the way we're going to do this is we're just going to differentiate both sides. We're going to use what's called implicit differentiation. So we'll compute d dx of the left-hand side, so d dx of sinh y equals d dx of the tangent of x. And is this the best way? I mean, you could use like inverse functions here, but I think this is from an old book from the 80s, and I think at this point in the book, they haven't talked about inverse functions. And this just seems easier. I mean, just taking the derivative, we can do that. It's really basic. Let's try it. So the derivative of sinh is cosinh, except here it's the sinh of y. So we're going to have to use the chain rule. So our inside function is y, our outside function is sinh. So it'll be cosinh of y, and then we leave the inside function untouched, that's our y, and then times the derivative of the inside, which is just dy dx. That's what we're looking for. It's the chain rule, right? Here y is a function of x. We're multiplying by the derivative of the inside equals d dx of 10x, that's just going to be secant squared of x. So now we can just divide by cosinh, So we end up with dy dx. So 1 over cosinh is going to be the, let me fix my equal sign there, I'm getting sloppy. 1 over cosinh is going to be the hyperbolic secant of y. And then we have secant squared of x. And that would be dy dx, right? 1 over cosinh is this, and then we're left with that. Kind of an interesting problem. This was thrown into the mix. Like, there's a bunch of problems in this old book I'm working through, and like, none of them are like this. And all of a sudden, like this one shows up with the y here. So again, just differentiate both sides and just use implicit differentiation. I hope this video has been helpful to someone out there in the world. Good luck to you.